the next thing we're going to talk about is chemical reactions. So the reason we did all the naming for all the different types of compounds is that we're now going to use them to create chemical reactions. So first thing we need to do is identify each different type of chemical reactions. And to do that, we need to know that there's two sides of an equation. We're going to have something here, plus something here, an arrow, something here, and here. So sometimes there might not be two things here and two things here, but it's going to generally have this sort of form. This side over here is called our reactants. These things on this side are going to react with each other, and they are going to produce these things on this side called our products. So our reactants react together, and they're going to go over here, and they're going to produce our products. So our first type of reactant is going to be a synthesis. So synthesis. So if this synthesis reaction is going to be two single elements are going to form together to make a compound. So you're going to have one element plus another element, and that is going to form a compound. So an example of this would be if I take, if I take calcium and I add it together with oxygen, that is going to produce calcium oxide. Let me just double check the charge on calcium. Here. So calcium has a charge of 2. Oxygen has a charge of 2. So when we make their compound, it becomes calcium oxide, and they both have 2s, and they reduce to 1. So a single element plus another single element produces a compound. This is a synthesis reaction. The next kind we're going to talk about is going to be a decomposition. So it's just going to be the reverse of the synthesis. Decomposition. So decomposition is going to take one compound and break it up into two single elements. So it's going to take that compound and it's going to break it back up into those single elements. So I can take the one from above and I can take calcium oxide, and then it can undergo decomposition and it can become calcium by itself plus oxygen by itself. So if you notice here, we have Ca is just Ca, but O is O2. We have what's called diatomic elements. So diatomic elements are elements that when they're found by themselves, they have a little 2 written beside them. So the diatomic elements are going to be hydrogen, nitrogen, fluorine, oxygen like seen above, iodine, calcium, and bromine. So all these elements, when they're found by themselves, so here oxygen is found by itself, it's going to have a 2 on it. We'll talk about this more later on when we actually start to balance these chemical reactions. Okay, so synthesis, decomposition. Synthesis again is 2 elements going to one compound. Decomposition is the opposite, so we're taking one compound, breaking it up into those single elements. The next kind we're going to talk about is going to be our single replacement or single displacement. So short times I might call them single, I might call them SD for single displacement, I might call it SR for single replacement. All of those things just means a single replacement / displacement reaction. So we're going to have a single element plus a compound. So single has a single element plus the compound, and that is going to also produce a single element plus a compound. Okay, so it's one single element plus compound. So I'd call it a 1 plus a 2. That's going to produce another 1 plus a 2. And what usually happens with these single replacement or single displacement reactions is that this A and B place elements are going to switch places. So the A and B here have switched places. That's what's happening. So we have A by itself mixed with a compound of B, C. What's going to happen is now the B is by itself and the A is going to be mixed with that C. So an example of this might be, let's say, aluminum plus copper chloride And what's going to happen here is I'm going to switch the Al and the Cu. So we have the A by itself and the B and the C. We're going to switch these two elements. We're going to switch aluminum and we're going to switch copper. And that's going to become copper by itself plus aluminum chloride. Double displacement. So sometimes I might just write double, it might be DD, might be DR. So double displacement or double replacement. It's going to have a compound and a compound. So instead of a single element, it's going to be a compound and another compound. So AB plus CD. So a compound and a compound. None of those are going to be singles. And that's going to produce, again, it's going to switch. So like it did up here, it's going to switch with the A's and B's. My A and C are going to switch. So it's going to become C and B plus an A and a D. So they're just going to switch about. Okay, so I switched the A and C is basically what I did. So the C went over with the B and the A went over with the D. An example of this, so and again, like the 1 plus 2 here, I call it a 2 plus a 2. That's going to make a 2 plus a 2. The 2's just means that there's a compound here. It's not one single element, where the 1 up here just meant there was one single element. So single versus double. So an example of double might be lead nitrate plus sodium iodide is going to then produce, oops, that's an awful arrow, is going to produce, so I'm going to switch the Na and the lead, so the lead and the sodium. So it's going to end up being lead iodide plus sodium nitrate. Just like that. So 2 things and 2 things. That's how you know it's a double displacement. We have 2 more types. Our next one is a combustion reaction. I need some more loose leaf. So a combustion reaction, kind of like it says, we're going to be burning things, combustion. So combustion is really easy to tell if it's a combustion reaction because combustion has to have certain parts. So a combustion reaction is going to have some sort of carbon and hydrogen compound, plus it has to have the oxygen, and that's going to produce something that has carbon dioxide and water. So combustion has to look like this. So on your reactant side, you're going to always have some random element of carbon and hydrogen and oxygen, and that's always going to produce our products of carbon dioxide and water. So an example of this might just be C4H6, and then plus my oxygen, going to produce my carbon dioxide and my water. So always going to have these 3 elements. Always going to have those 3 parts. That's what makes combustion. And then the last one is a neutralization reaction. And again, neutralization looks a certain way. So neutralization is going to be some sort of acid plus some sort of base to produce a salt of some sort and our water. And our water is always H2O. So how we know something's an acid, it's going to have an H, and it's going to have a hydrogen ion in it. Something that's a base is going to have a hydroxide ion in it. So that's just a little cheat sheet to help you know that what's an acid, what's a base. Most times you can always ask me or ask your teacher if it's an acid or a base. So an acid is something that has an H in it though, easy little cheat sheet, and a base is something that has an OH in it, so another little cheat sheet. Salt is going to be anything like NaCl, NaBr, something that might have phosphate in it, things like that. Those are all examples of your salts. And then water is always going to be H2O. So an example of this might be H2SO4. So again, this is an acid because it has an H in it, plus CaOH2. So again, that's going to be a base because it has an OH in it. It's then going to produce some type of salt, like NaSO4. So SO4. So you can always, again, ask me or ask your teacher if that's a salt. And then plus that water. So as soon as you usually see plus that water by itself, that's usually when you know it's a neutralization reaction. And also you're going to have that H and that OH ions in it. Okay, so watch out for those. And that is it. So again, we had our synthesis, our decomposition. Those two kind of go hand in hand. We then have our single displacement and a double displacement. Again, those are very similar. And then our ones that are very distinct are our combustion reactions and our neutralization reactions.